Alright, in this very first video, we're going to talk about limits. So the foundation of all calculus is the concept of a limit. We need to understand a few things about limits in this lesson. First one, what is a limit? How is a limit similar or different than a point on the graph? And then how do we write the limit statements and how do you read a limit statement? So we're going to do a first, then we're going to look at this first example. There's three different graphs, and if you look below, they all have the same limit statement besides the function. So it says a limit is a y value that a graph or function gets closer and closer to, but maybe not actually get to, as the x values get closer and closer to that specific value from both sides. So if you look at this first one, it's the way we read this is the limit of f of x as x approaches 3 is 2. That's how you read it. Or you can read it as the limit as the x approaches 3 of f of x is 2. You can go interchangeable with that. But if I'm looking at it, I'm looking at the graph, and the limit as the x is getting closer and closer to 3. So as my x's get closer and closer to 3, the y values are getting closer and closer to 2. It doesn't actually get to 2. The function is not defined at 2. That's why there's an open circle there at 2. But the limit of the function, f of x, as x approaches 3 is 2. This next one, it's the same limit statement. But this function, the function value g of 3 is defined to be 4. But the limit of g of x as the x's approaches 3 is also 2. Because look at the definition of a limit. The limit is the y value that your graph gets closer and closer to, but it maybe not actually touch, as the x's get closer and closer to that specific value. So as the x's get closer to 3, the y values are still getting closer and closer to 2. Even though the function is defined to be 4 when x is 3. So the limit's still 2. The limit of this last one doesn't look as exciting, but the limit of h of x as x approaches 3, what are the y values? Oh, it looks like it's 2. So the limit is 2. So all three graphs have the same limit as x approaches 3. All right, what is this? This is the exact same thing. Okay, so talking limits, the way we read this is I already said this, is the limit of f of x, so the limit of f of x as x approaches, I don't know why I'm writing this down, it says it right there, 3 is 2. Now the other way you can say it is the limit as x approaches 3 of f of x is 2. You could say it either way. I usually say it the first way, but it's correct either way. All right, let's look at some more challenging questions. So if you're having trouble with the idea of limits as, maybe this will help you. It says this whole thing about Taco Bell. The way I heard this when I was in high school was, like does it meet up? So if you're going to Taco Bell, you and your friend, are you going to meet up at Taco Bell? So the limit is defined if you meet up at Taco Bell. And I don't know if that makes any sense yet, but let's see if it makes sense. So the limit of f of x as x approaches 9. So I'm going to look over, okay, here's 9. Here's where x is 9. So I'm coming from the left. I'm going to meet up with my friend. So my friend's going from the left, or I'm coming from the left, my friend's going to the right. It looks like we would meet up. Would we meet up? Yes. Now, there's an open circle there. That means the function is not defined there, but the limit is still that y value that's getting really close to, which is -1. So if you were like thinking about this, like this Taco Bell just moved. So if I said, okay, let's meet at that Taco Bell over there where, I guess there's one over there by that McDonald's and QT over there in Euless, and let's say, okay, we're going to meet there. We both know where that is, but we go there and the Taco Bell is shut down. So that would be like an example of the limit still there, but the Taco Bell's not there. But we still met up there. All right, so number 2, what's the limit of the function f of x as x approaches 5? So I'll look where x is 5. It's right here. What is the limit? So the limit, if you go back to the definition, it says from both sides. So it has to be, the x's have to get, or as the function, as the x's approach the number that you're looking at, the left-handed and the right hand has to be coming to the same thing. So if I'm thinking about, would we meet up at Taco Bell here? So I'm coming from the left and I'm here. My friend is coming from the right and he ends up there. Maybe this is where the Taco Bell and his GPS was, and he put in the Taco Bell, but he didn't update his iPhone. So he went to where the Taco Bell used to be, and my GPS is updated, and it took me to the Taco Bell. So I'm at Taco Bell, he's at where Taco Bell used to be, but did we meet up? We did not meet up, so this limit does not exist. From now on, we're going to write DNE for does not exist. So the limit doesn't exist if the function is not approaching the same y value from the left and from the right. All right, so hopefully that makes sense. Think about Taco Bell. If you met up at a Taco Bell, if you meet up, the limit exists. If you don't meet up, the limit doesn't exist. All right, the limit as x approaches 3. Okay, well, this one's kind of tricky. There's this dotted line here. You might remember from your previous math days is an asymptote, a vertical asymptote. So here, our graph would get really, really close to that vertical asymptote of 3, but never touch it. And if I'm looking at this, if I'm getting really close, really close, really close, would me and my friend meet up at Taco Bell? No, we would not meet up, so we would say this limit does not exist, or D and E. Even though I guess you could say the limit as x, from the left side it's approaching infinity, from the right side it's approaching infinity, so it's the same, but we didn't meet up. That's why that one doesn't exist. All right, the limit as x approaches 1. So here's 1, where x is 1. From the left, that's me going to Taco Bell. My friend's going to Taco Bell. Is Taco Bell there? No. Taco Bell has moved, but we did meet up. So the limit exists because my friend and I, we met up from the left and from the right. And the y value is getting closer and closer to is 1. All right, the next notation might be something new that you've never seen before. Number 5. It says the limit of f of x as x approaches, should that be -5? What is that? Is that just a typo? No, probably not a typo because there's something over here. So I want you to think to yourself for a second. What do you think that means, that little notation of a little negative right there? Okay, that actually means from the left. And we'll talk about this in a second. But this is read as, what is the limit of f of x as x approaches 5 from the left? So this one, we don't have to really worry about meeting up with our friend. It's just saying, what is the y value? What are the y values getting closer to as x approaches 5? So here's 5 from the left. So from the left, it looks like the y values are getting closer and closer to 1. So we just say 1. I'm not worried about meeting up with my friend at Taco Bell on just the left hand, the one-sided limit. That's what that's called, just from the left. All right, so number 6, what's the limit of f of x as x approaches 1 from the right? So from the right, here's 1. From the right, the y values are getting closer and closer to 1. This one would be the same from the left and from the right. But that one, if it's just saying from the right, you don't really worry about it. If you meet up with Taco Bell, it's just what is the limit? All right, number 7. Don't forget everything you've learned about Algebra 1 or Algebra 2. Just f of 1 means what's the function value at 1. So what is the function defined to be when x is 1? Okay, x is 1. The limit, which is what we did on number 4, was 1. But the function value is actually 2 because there's that point right there. All right, so number 8, f of 9. Here's where x is 9. Plug in 9. I don't see any point where it's defined to be. It's an open circle, so I'm just going to say D and E. It does not exist. All right, this is one I want you to try, maybe on your own. You can pause the video, try these 4, and then come back to it. All right, so now you're back. It says use the graph of g of x to answer these questions. So the limit of g of x as x approaches 4. So this is a two-sided limit, not just one-sided. So I can think about it like meeting up my friend with the Taco Bell. So at 4, from the left, from the right, they're approaching the same number, the same y value of 1. The limit of g of x as x approaches 1 from the left, from the right is not approaching the same thing. My friend and I would not meet up, so I would say D and E. G of 4 is just the function value at 4. So if I plug in 4, what would I get? I would get 2. And the limit as x approaches 2 of g of x, so here's 2. So what's the y value as you come from the left and from the right would be 1. I should probably have put this slide in earlier, but oh well. It says the limit of g of x does not exist because, as x approaches 1, does not exist because we are approaching 2 different y values from each side of the graph. This brings up the idea of a one-sided limit, which we talked about. So this is how you would denote a limit from the left, the little negative. So it's like an exponent in the top right, and then this would be from the right, from the positive side, and then from the negative side would be from the left. All right, the next thing was our brain break, but let's just keep going. All right, so here's a couple more problems that you could do on your own. You pause it right now, see if you got this down, and then come back and check. So we'll kind of speed through this. All right, so if you pause it and come back, it says use the graph of h of x to answer the following. So one-sided limit as x approaches 3, it's just going to be 1. As x approaches 2, looks like here's 2. It's not the same from the left and the right, D and E. 2 just from the right, okay, now I don't have to worry about. So I'm just saying what's the y values getting closer and closer to? It'll be 0. H of 1, the function value at 1 is 1. The limit as x approaches negative 1 from the left, so here's negative 1. From the left, the y value is getting closer to 2. Negative 1 from the right would be negative 1. Okay, just double limit, so double-sided limit. X approaches negative 1 period, since it's not the same on the left and from the right. These did not equal, right? Those weren't equal to each other, so we would say D and E. H of negative 1, function value at negative 1. I don't see any points, so I would say D and E. All right, the next thing is something we would do in class. This would be in class. There's a whole bunch of answers you can do with this, but we're going to skip over it. Okay, last question is an actual AP question on the actual AP exam from the past. So pause the video, see if you could do it, and then we'll talk about it when you come back. So it says the graph of y equals f of x is shown above. What is the limit of f of x as x approaches 1? So it doesn't say from the left, from the right. So from the left, from the right, they're at 1. They don't match up, so I would say the limit does not exist, or D and E. So if you said 0, this would be f of 1. That's the function value. If you said this would just be the right-handed limit, and then this would be the left-handed limit. But what it's wanting you to know is, do you understand that the limit, if it's just not saying from the left or from the right, it has to match from both the left and from the right, so it doesn't exist. And that's just it for the first video. If you have any questions, ask in class next time I see you.